So now let us talk about priority queues and heaps. Today we are going to see priority queues. We have seen earlier in the class that there are two simple data structure which we employ to manage access to our data and shared resources, namely queues and stacks. So what this stack does, it accesses the data in LIFO, last in first out order. While in contrast, this FIFO is the underlying technology for queues. And in real world, this is ethical also, that whenever it comes to you first, you should give your time and your favor to him or her. And this is in every aspect of life. Like you are standing in a restaurant or a grocery store, then you should be treated first, or the other person who has come before you, he should be uh, given priority. So the word priority comes. Why? Because you have a restaurant. Just imagine you have a restaurant, you booked it with your credit card, and now you went there, you have a reservation, and sorry, you don't have a reservation. Then what you will do? Then again, sorry, you have to have a reservation. If you have paid, you should get a seat of your choice. Now take some other example. This is very general purpose. Now if an aeroplane is there and some emergency comes, it has to land. We have to give the priority to the aircraft which is in trouble. Seriously, a person who is gunshot or has just had a heart attack, suffered a heart attack, then he has to be prioritized, not the person who is having a cold. So all this discussion comes, then we need to talk about this priority queue that address these things only, which is an abstract data type. You know that this ADT has a different type of operation associated with them. So the key ability are, for this priority queue, it has to have an addition of an item with some certain priority, returning the item with the highest priority, deleting the item with the highest priority, and etc. Now there may be possibility there's two priorities may be same, means you can have an element or objects which have same priorities. So how to you take care of them, which of them have to be favored prior to other. We'll see it just now, but before that we need to see the comparison, because we need to find out that if two has same priority, or which has the higher priority, we need to find out the highest priority. What we can do, the first is that we can have a data type, and it is powered to compare the objects, means overloading the comparison operator. We can overload. So we have two objects, say A and B, of some time t. A less than B can be a comparison of the priority. So the object which is having the greatest priority has to be served first. So the priority will be embedded inside the object itself. But there is other option also. We can add a new item in the priority queue, and we'll tell the priority queue what the item priority is, and the priority will be kept separately, means in the form of say integer. So the queue needs to store two things for each item, that is, you have a data and the priority. And in this particular approach, the priority is determined only when the item is inserted, right? So the first method was perhaps it seems right now too easier to implement, but the second is more flexible. So as we have talked about, let us see how your priority queue function will look like. How it is, you can have a template or just name a class priority queue. You have a function which is called add. You add this item. Peek means you find out the highest priority item. Remove means you remove the highest priority item, Empty, you check the priority queue is empty or not. You change priority. You can change the priority of an item. So all this discussion can be can be applied on various systems, even for the games, artificial intelligence, changing of state, exploring the priorities and changing the priorities. All this can be done, right? So these are various aspects, but there has to be a tie break situation also. Means all this discussion is just general purpose. So the basic idea is to have a tiebreaker if the priorities are same. Just by having a priority you cannot find out. So you can have a solution for this. You can have a original priority and additional time. If the priority are same, the time can be a factor on which the tiebreaker can be applied. Let us see some implementation of priority queue. Priority queue, as the name has queue in it, then this is general, thought that okay, let us implement as the queues are implemented. Will it be? The two name implementation of these priority queues can be, say, linked list or array. We will use sorted and then unsorted. So for a linked list or an unsorted array, or you can use list type also, when we add an element, you see, and this is an unsorted element. So you add an element, you can add it to the tail or to the head, no problem with that. So the order will be, or the time will be theta1. You need to peek means find out the highest priority element, then you have to search because this is unsorted array. Array has unsorted element or linked list is unsorted. You have to go right from the beginning to find out the element. So that will take theta and time. Then you need to remove. For remove also you need to first search. For that you have to do linear search. Again the time is theta n. That is why linked list or unsorted array, they are quite good for inserting element, but they are not advisable for this order n, picking and removing the values. So now we can have some alternative approach also. Let us have a sorted array, and the implementation would be, we need to search an element. To add an element we need to search the current position, and because these are all ascending or descending order, we know that the highest will be here, lowest will be here, and vice or likewise. So we can just go to the mid one and then find out whether the value is there or not. If it is not found, we can go to this left or right, and so the order will be order of log n. And once you want to find out, once you found the value, then you have to add. So you have to make a way for it, make a position, make a home for it. So that will take theta and time. And to peak, because this is ordered, so theta1 will be the time. You can easily find out. How to remove? You can easily go to the highest one, means the tail or the front, and you can just remove it. So the sorted array or linked list is fast in these two cases, picking and removing, but if you want to add, they are not. So this was the basic idea of priority queues. We'll be seeing heaps in just a bit. Thank you so much.